Well, hey, everybody. Welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to the podcast. So on today's episode, we are going to talk a little bit about electric vehicle power and Article 625 of the National Electrical Code. So I got a lot of questions people ask about EV vehicles and all the rules that are associated with that, and we're going to talk a little bit about that today. Well, obviously, we're not going to go in everything about an EV vehicle. Obviously, we can break that down into multiple sessions. But again, when it comes to dealing with EV vehicles, there's some of the basics that people ask about all the time, especially for exams. And of course, with EV vehicles, we have this advent of need for ventilation and things like that. That something wouldn't be typically what you would see at, say you have an EV vehicle that's going to be something like a Prius, which is a PHEV, by the way, and all of those type of things. And you're like, well, what are the rules associated with that? And it's not that it's new, but there is applications with these things that, they can supply power. They can actually, send power back to this to the building. And of course, we can charge the vehicles as well. So a lot of things to talk about when it comes to PV. I guess the first thing we should always do is talk about the scope of 625, which is .1. And here's what it says. It says, this article covers the electrical conductors and equipment connecting an electric vehicle to the premise wiring for the purpose of charging, power export, or bidirectional current flow. So again, using it as a source of power potentially back to the actual premise wiring. So again, covers all this, and of course there's some informational notes for those that want to dig deeper. There's some UL standards for electric vehicle supply equipment under UL 2594. Go check that out if you're inclined to do so. There's also a UL 2202, which is dealing with a standard for electric vehicle charging system equipment as well. So feel free to check those out at your pleasure, if you will. There's also an NFPA document, NFPA 505, which is the fire safety standards for powered industrial trucks, including type designations, areas of use, conversions, maintenance, and operation. Again, that's for industrial trucks and whatnot, all that kind of good stuff. So anyway, there's some great information there in those other standards, all of which we will not talk about today. No, we're just going to stick to Article 625. I don't get into these other standards. In fact, to be honest with you, I serve on committees for UL, but I find those the most boring documents in the world. I'm sorry, UL, I just have to say it. All right, so, and ironically enough, being a code guy, they're not written to me the same way as we read the NEC. So I'm a big fan, obviously, of the NEC. So, all right, so let's kind of look at, so that's the definition. That's what we're talking about. We do have some definitions under 625.2 that we should be aware of before we dig into this first part. And again, this is what we're going to talk about part one in this episode, kind of give us an introduction into electric vehicles. So we've got some definitions. And again, .2 is definitions that are pretty much germane only to this article. And any definition that's used in more than one articles is going to find its way over to Article 100 of the definitions in the National Electrical Code. Heads up, that will change in 2023. And if it goes through, pretty much all the definitions in .2 will get moved to Article 100. So Article 100 is going to grow, and it's going to have all the definitions that are spattered throughout the .2 and relocated to 100. So the language where it's used in two or more articles is going to go away. But again, I'm trying to jump in the gun telling you about stuff that we're working on for 2023, and it's probably a bit premature at this point. So let's look at some definitions. So we got cable management systems. That's a definition. It's an apparatus designed to control and organize the output cable to an electric vehicle or to the primary pad. Okay, so we have a cable management system that's going to encompass that. Let's see here. what's next in the next one? The next one is charger power converter. It is the device used to convert energy from the power grid to a high frequency output for wireless power transfer. Okay, so I guess you have an application where you got the power grid supplying power, high frequency output for a wireless power transfer. And I can only think in my mind, being I'm not an expert, in my opinion, on electrical vehicles, but I'm assuming it's just like your car. You pull it over and it charges it wirelessly. Okay. Electric vehicle connector. So a device that, when electrically coupled, that's conductive or inductive, to an electric vehicle inlet, establishes an electrical connection to the electric vehicle for the purpose of power transfer and information exchange. Obviously, a communication between the charging unit and the vehicle itself. So that's an interconnector that's actually doing the communication between the two. And there's an informational note there that reminds you to go to LIC 625.48 for interactive systems back and forth. Now, what we get into next is electric vehicle power export equipment, and that's an EVPE is the acronym. And you're going to see a whole lot more acronyms in the 2020, and you're going to see a lot more in the 2023 as well, as the acronyms are starting to be worked out and used in different areas of the code. So the electric vehicle power export equipment, EVPE, is defined as the equipment including the outlet on the vehicle that is used to provide electric power at voltages greater than or equal to 30 volts AC or 60 volt DC to loads external to the vehicle, using the vehicle as the source of supply. Okay, so exporting the power out of the vehicle where the voltages are greater or equal to 30 volts AC or 60 volts DC to supply external loads. That is electric vehicle power export equipment, EVPE. And of course, where utilized in the code for EVPE, that is where you'll see that definition used. Okay. The next one is EVSE, which is probably going to be used the most. That's electric vehicle supply equipment. And what does all that cover? Well, that covers the conductors, including the ungrounded, grounded, and equipment grounded conductor. All of that's part of the EV supply equipment. And the electric vehicle connectors, attachment plugs, personal protective systems, and all other fittings, devices, power outlets, or apparatus installed specifically for the purpose of transferring energy between the premise wiring and the electric vehicle. So when I go out and I'm going to buy a EVSE system and I'm going to charge my Tesla or whatnot, if I had a Tesla, there's just a massive recall on these Teslas. So these batteries, it can, I don't know. Anyway, so you have this charging system, and that is part of the EVSE, the cords and everything associated with it. And as far as this is concerned, the actual conductors, including the ungrounded, grounded, and equipment grounded conductors, and all of that is part of the EVSE. Okay, so that's electric vehicle supply equipment. There is an informational note here that it's worthy of reading. Again, remember, informational notes are just information only. They're great information. They're not enforceable, but again, they're like roadmaps through the NEC. So we always want to pay attention to an informational note. So it says electric vehicle power export equipment. We already kind of saw what that was. And electric vehicle power supply equipment, which we just looked what that is, are sometimes contained in one piece of equipment, sometimes referred to as a bidirectional EVSE, right? So again, it can charge the vehicle, but it can also give power back to the premise wiring system, okay? Then we got some other definitions. Let's see here. Fastened in place. So within 625, when there's a reference to something fastened in place, then we've got this definition. It says, mounting means of equipment in which the fastening means are specifically designed to permit periodic removal without the use of tools for relocation, interchangeability, maintenance, or repair. Okay, so the mounting means of the equipment in which the fastening means are specifically designed to permit periodic removal without the use of a tool, that type of thing. So It's fastened in place by a mounting means, and it's designed specifically for, again, removal without the use of a tool, for relocation, interchangeability, maintenance, or repair. Okay, so it's still considered fastened in place. Now, fixed in place is the next definition. And it says mounting means of an EVSE attached to a wall or surface with fasteners that require a tool to be removed. And that tool could be something as simply as a necessary need for a screwdriver or a drill with a bit in it that has a screwdriver end on it, Phillips, flathead, whatever, hexagon, whatever it may be. So a subtle difference. I think for me, it's the fasten in place is all the component pieces. The fixed in place is very specific to the EVSE. And again, of course, you have to remember that the EVSE is also defined above in electric vehicle supply equipment, which again includes the conductors, including the ungrounded, grounded equipment, the connectors, attachment plugs, and all that type of stuff, which is, again, when the building wiring is going to supply to this charging system, then that's actually going to be fixed in place wiring, that type of thing. Now, if there's a cord going from that unit to the end handle that goes into the actual vehicle, all of that connects to the actual charging system, all of that's part of the EVSE, but that would probably more towards the fastened in place rather than fixed in place, so that, again, the cord's going to be removable, flexible, things like that. Okay? Again, that's just my interpretation of it. You can agree to disagree, all we would like. So the next is output cable to the electric vehicle. So this is going to come from the EVSE equipment. That's the charging main base. And this is the output cable to the vehicle. And it says it's an assembly consisting of a length of flexible EV cable and an electric vehicle connector supplying power to the electric vehicle. So this is the port handle that you're going to plug into the vehicle, whether depending on what type you have, type 1, type 2, type 3, type chargers, whatever you have. Again, it has a lot to do with how quickly they charge. So that is the cord from the charging station over to the actual EV vehicle. The next one would be output cable to the primary pad. So it says a multi-conductor shielded cable assembly consisting of conductors to carry the high-frequency energy and any status signals between the charging power converter and the primary pad. Well, we don't know what a primary pad is yet, but we do have a definition coming up here in a few moments. But that's what that is. So this is the output from the EV unit to the actual primary pad, and I'm assuming the primary pad is what's going to allow to give the signal, transfer power, contactless, okay, coupling between the wireless power transfer and the actual vehicle, which is kind of like your phone, in my mind, sitting on top of one of these wireless chargers, okay? Kind of heck, if you can do it for those, you ought to be able to do it for a vehicle, right? They seem to be close enough, right? So anyway, makes sense. You put it in the floor, you pull up over top of it. Makes sense, right? All right, you don't have to hook up anything. Just right over top of it. All right, so in case I'm totally missing this, I'm sure somebody will enlighten me in the comments. Again, I don't do a whole lot of his electric vehicle things, and I'm not even sure I want one at this stage. But, when I read the reports of Tesla recalling, 160,000 or 180,000. Now, I think the Prius is a pretty good, okay? Don't be bashing me because it's a Prius. I like the concept. I like the Volt. I like the concept of those PHEVs. I like the concept of being able to have fossil fuel and electric. In case I run out of electric, I can run on fossil fuel, and maybe the fossil fuel will charge my electric battery so that at least I can, get to where I got to go. I don't like the idea of just being electric. Just me. Some people are just all on board, right? Everybody's, fully in. I don't know that I'm fully in yet on that, like those Nissan Leafs or whatnot. I don't know that I want to go out and think, because I'll be honest with you, I'm having issues with one of my phone batteries simply just dying out of nowhere. It has a full charge and all of a sudden it's dead. I'm worried that what would happen if my vehicle did that? I don't know. That's just me. I'm just old-fashioned. Anyway, I do like the idea, though, of the hybrid stuff a little bit better than I do full-on electric vehicle, but that's just me. I know. I'll get over it, I guess, in time. What's next? Okay, so that was the output cable to the primary pad. The next one is personal protective system. This is a definition. It's being used in 625, and it is a system or personal protective device and constructional features that, when used together, provide protection against electric shock of personnel. So it might be some system that is built into the EVSE equipment that's going to provide this level of personal protection system. I will note that it might be in the form of a GFCI, maybe built into the system or something. But at this point, personal protective system, we'll just have to see how that rears its head as we continue to examine 625. The next one is portable. And this is portable, and the term portable as it applies to EVSE. And we've already defined what EVSE is. It says a device intended for indoor or outdoor use that can be carried from charging location to charging location and is designed to be transported in the vehicle when not in use. So again, portable EVS chargers, probably for things like the Leafs and whatever. I don't think that you're going to be portably charging a Tesla. I'm just saying, the charging level's too high. Unless you want to wait 18 hours to charge a daggone thing. So as it applies to EVSE, portable, okay? It's an indoor device used indoors or outdoors that is designed to carry from charging location to charging location. So I'm going to charge here, then I take it with me in my car. I think like the Priuses have different things and things like that Leaf probably has it where you go to one location, then you can go and plug it in a different location and you can charge. So that's a portable EVSE. Power supply cord. That's the next definition we're going to look at. It says an assembly consisting of an attachment plug and length of flexible cord that connects equipment to a receptacle. Okay? So the power cord is going from the actual EVSE equipment, and it is flexible, specific length, and it will connect the equipment to an actual receptacle. Okay? And that's a power supply cord. Primary pad. Here we go. So we have a definition of a primary pad. I kind of alluded earlier to it, kind of what I thought it should be. But here's what it says. It's a primary pad. It's a device external to the EV, electric vehicle, that transfer power via the contactless coupling as part of the wireless power transfer system. Now, that just sounds high tech, right? That just sounds like, it's just like me putting my now this has to be some pretty good output. I can imagine the people out there that are worried about EV, this scenario here with a wireless, the primary pad. I can hear the people out there, because there's people out there again that are worried about, different voltages and all this type of stuff, and it freaks them out to think that, okay, well, I could be in a situation where this much frequency is being put out in order to be able to charge my vehicle because I'm just driving over top of it, right? And there's tons of people that are worried about EMF transmissions and the level of that and all that kind of stuff. And so anyway, this is just a whole nother thing that hopefully they're doing all kinds of testing on, and I'm sure they are. All right, so next is wireless power transfer, EPT. And it says a transfer of electrical energy from a power source to an electrical load via electric and magnetic fields or waves by a contactless inductive means between a primary and a secondary device. Okay, so it seems to me you have your primary pad, and then the secondary device is going to be in the vehicle, and it allows it to do it that way. Okay, so with that wireless power transfer, we have to have what's called wireless power transfer equipment, and that's acronym is WPTE. All kinds of different acronyms going around in the NEC here. So it's equipment consisting of a charger, power converter, and a primary pad. Okay, the two devices are either separate units or contained within one enclosure. Okay, so the wireless power transfer equipment. That's the overall equipment. And we have a definition of what wireless power transfer is supposed to achieve. We looked at that definition. And of course, then we have the primary pad, which is going to do the work from the point where the vehicle, I guess, pulls over top of it. And we have the transfer that way. I'm assuming that's how it's going to work. And again, I've got my phone in my mind when I'm thinking of wireless power, things like that. That's what I'm thinking of. Now, I've been telling you right off the bat, I don't have any insight, any special wisdom, any private knowledge. So if anybody out there is in the EV world that wants to send me that information or would love to have an EV expert come on our show on Electrician Live, would love to have you. I'm sure Jay and me both would love to have you and ask questions about EV systems and help you get that word out. But again, we want a true professional, somebody that works in the industry, not just somebody that's another code guy. Look, we need people that are actually the manufacturers or somebody representing the manufacturer to talk about these type products. That's all I'm saying. All right. So the next thing we've got is we're out of those definitions. We're out of .2. We just kind of read them so that we can kind of relate to them as we encounter them throughout Article 625, because I'm sure they're going to be used in other areas. So we just want to get a good understanding of it. Hopefully you've pulled out your code book, and if you looked as well, obviously you'll know we're in the 2020 edition of the NEC. So again, should not be brain surgery at this point. These are just a bunch of good definitions to be aware of. And again, they're germane to 625. The next would be voltages. So 625.4 is dealing with the voltages that are associated with Article 625. And Section 4 is dealing with that. And it says, unless other voltages are specified. Okay, and when it says that, it means in case anywhere else in here it gives out another voltage class, it says the nominal AC system's voltage of 120, 120, 240, 208Y, 120, 240, and 480Y, 277, 480, 600Y, 347. That's more Canada, I think, even though maybe some areas out there that might utilize that. 600 and 1,000 volts and DC system voltages of up to 1,000 volts shall be used to supply equipment covered by this article. Okay? So we have, really, to be honest with you, that's the full gamut of voltages that we typically deal with here in the NEC anyway. So again, more of a regurgitation of what we should at this point already know when it comes to the various voltages and things like that. Okay? But it's just always good to rehash it again, make sure we know. And again, well, hopefully the manufacturer's going to take care of that. Obviously, we not buy a EV vehicle and have a charger put in or whatnot and it not work within the scope of the voltage we're dealing with. So again, all these seem to be covered here pretty well. And then the last one in part 1 is 625.5 listed. It says all equipment covered by the scope of this article shall be listed. So that's the beautiful thing now. Whether it's an EVSE, whether it's a WPT, WPTE, which is the wireless power transfer equipment, all of that stuff is going to be listed. So it's going to have to meet the listing requirements as well through evaluation bodies. Means it's whoever the evaluation body may be, third party. You have a UL ANSI standard that we talked about, and then you'll have other people like UL has a certifying division and listing division and compliance division, and what do you've got? ETL with Intertech, and all of them, if they're capable and they're listed as an NRTL to be able to do the evaluation, then all these products will be evaluated to make sure that they meet their original intent. And if that's the case, then they'll all be listed, and then we don't have to worry about it. We're just going to buy all listed products, and we're good to go, right? So anyway, hopefully that's what we got in. Hopefully you got something that's out of part 1. Next, we'll jump into part 2, and we'll learn a little more about these systems and start digging into some of the meat and potatoes about it. Until next time, folks, stay safe. God bless.